Given that a is greater than b, which is greater than 0, and that a and b satisfy this log equation, show that a equals b squared over b minus 1. Now the restrictions come in because you can't take log of a negative. That's why a has to be positive and b has to be positive. And we also need a to be greater than b to make this term positive. There is a rule of logs when we're doing log a minus log b, but it's not to subtract them inside the bracket, it's actually to divide them. This question's looking at a special case where it's actually going to be true that we could subtract them. But this one is always true, well, at least for positive a and b. So for part A, I can replace the left-hand side by log a over b and set it equal to log a minus b. Then I can remove the logs. It must be that this is equal to this. A over b equals a minus b. You can alternatively raise both sides to the power of 10, the inverse operation which cancels these out. I want to make a the subject now, so a is equal to ab minus b squared. I've got a fraction, I've got it on both sides, so I just need to mess around with it algebraically. I'm going to add b squared and minus a. Give me b squared is ab minus a. Factorize out the a now. And finally, I'm going to get a equals b squared over b minus 1 as we wanted. In part B, we're asked to write down the full restriction on B, explaining the reason for this restriction. So we know that B is greater than 0, but is there anything else that comes in? Well, we know that A is greater than B, but that won't necessarily happen because if you have B squared and you divide by 1 less than B, you're going to get something that is greater than B. Because if you replace that, then A would equal B, but if you then divide by something smaller, A is going to be greater than B. So that, I don't actually need to worry about that. It's all about the A being greater than 0 actually, because it must be that B squared over B minus 1 is also greater than 0, since A greater than 0 and A equals B squared over B minus 1. I think that's implied. That's where I got it all from. So I know that the top is always positive or 0 to be fair, but actually it's greater than 0. B is greater than 0, so B squared is greater than 0. So what we actually require is that b minus 1 is also greater than 0. I'll also be divided by a negative, and I would get a negative overall. And therefore, I actually require not just b greater than 0, but b greater than 1 for this to be true. So nice little add-on to this question. Yeah, good.